I've always had interest as a child collecting rocks and fossils, and mainly anything to do with natural history. My general interest is in wildlife, natural history, and it sort of evolved into geology via that. An element may have different forms, and these different forms are called isotopes. We look at the variation of the different amounts of these isotopes in different materials and how they change over time. So we look at this different composition of the isotopes. So we can look at different materials, a fish ear bone for example, and see where it's lived over its life cycle. We look at climate change, pollution, environmental science, environment, geochemistry and health, and obviously dating of rocks, which is one of our key applications, and we're one of the foremost labs in the world in dating of rocks, both with lasers and high precision work where you dissolve up the sample material and analyse it. A study we did a little while back was to look at air pollution in London, and they collected filters from sampling stations along the sides of roads, and you could see the change in the lead isotope signature as leaded petrol was phased out, and you could then begin to see the pollution sources that were additional from local areas, but also as the wind directions changed you could begin to see also contamination and pollution coming over from Eastern Europe. One of my career highlights was when I was working in Zimbabwe as part of my PhD training, and I sampled a rock there that looked very unusual to me, and I took it back and I dated it, and it turned out to be 3.7 billion years old and one of the oldest rocks in the world.